Hi calculus student, this video is 5.2 part 1 definite integral. So we actually is going to find out the area under the curve. So we talk about if we can the definition of the area under the curve is cut the rectangles really small so that they are infinitely many, and then every one of them would be f of xi, like the height of one of the values in the partition times the delta x, the width of the rectangle, and then if we add them together, it should be equal to the area. And this is only defined for non-negative function. That means the f of x has to be above the x-axis because we're talking about area. So, but then we want to generalize it so that we don't limit to f of x in a non-negative function. We allow f of x to be like below the x-axis. So that's why we have a new definition of kind of not area but signed area. You can say release the condition for non-negative function and redefine a new notation called a definite integral. So what is definite integral? We would write the integral sign, and then the boundary is of the area is a to b. We write as a from a to b, f of x dx. So this would equal to limit n approach infinity, sigma I equal to 1 to n, still f of x sub I star in that partition, the partition of xi minus 1 and xi. We pick any number, most likely is the right boundary actually, and then we pick this boundary as our rectangle. So our graph could be like somewhere like this, but we'll pick this one. And then this would be our rectangle to represent that particular partition, and this size is delta x. And what is delta x? Delta x is, this is delta x. Delta x is always b minus a over a particular n. But overall speaking, our n is approaching infinity. So this is the definition of a definite integral. It is a number. It represents an area. Although the area might not be positive, it could be a negative number. If it is below the x-axis, it's a negative number because on top, if f of x is on top, then this is positive number. And if your function is below like that, and then you have area under the curve, so that's the under means attached to x-axis. This is negative area and this is positive area. And if you add these two area together, sometimes they cancel. So this is called the definite integral. Okay, so f of x is called the integrand, is the function that bound the area. AB are called the limit of integration. X is the variable of integration. So you can use t, you can use u. It's just saying that this is the variable. This is how you name the function. You can use another variable. There is also a finding that we see that if f of x is continuous, then you can actually find the limit. So if it exists, then this is a we call f is integrable in AB. So notice the difference between the indefinite integral in chapter 4.10. We talk about indefinite integral. This one, f of x dx. This gives us antiderivative, right? Antiderivative is a function. It's a family of function. Antiderivative plus c, right? But definite integral is like this. AB f of x dx is an area, is a number. Equal to area, signed area actually, equal to a number. So there are two different things. Why are they using the same symbol? Because actually they are related. In 5.3, in the next section, we'll talk about it. So, so from now on, whenever we want to say we want to find area, we can actually write a definite integral to represent it. So this is very small. This function is f of x equal to 4x minus x squared. It's very small. 4x minus square is this function, and this shaded area, how can you write it? You no longer have to say function area between 0 to 4 under the curve of 4x minus x squared. The new notation would be integral from 0 to 4. What is the function? 4x minus x squared dx. This means this area, because this is a new notation called definite integral notation. If I have a function x plus 2 and I want to find area from 0 to 3, I'll write this as this area is equal to, meaning this shaded area is bound from 0 to 3, because it's the boundary is 0 to 3. What is the function that is under x plus 2? Dx. So this is because this is actually the Riemann sum representation. So how do I evaluate this kind of integral, definite integral? I'm supposed to get an area, right? So this lead us to several directions. One is actually calculate the limit. Last time we write the Riemann sum out, but we never calculate the limit using right endpoints. So we are going to actually do the limit to infinity. So, but this is the most difficult part, and also it's very hard to do if it's not in polynomial. Okay, if it's a sine, cosine, or e to the x function, it's very hard to pick a good f(x) of n. The second way to calculate this a, b, f of x dx is you use geometry formula. Suppose just like this one. If you look at this area, although you can write it this way, actually it is a trapezoid. You can actually calculate it, right? So you can calculate the area by geometric formula. It is signed it. When it is below the x-axis, you use negative sign to represent the area, so you can add area together and they can cancel each other. Okay. If it is represented in a definite integral notation. The third way is use properties of integral to find integral from other definite integral. So that means suppose earlier we find a function and we already know this area, someone did the limit for us or whatever, and then we can use this to find, some other one. So properties of a definite integral, we'll talk about this. And then lastly, which is the most easy one, so this is very difficult. Supposedly it works for every single function, but some of the function you can't. It's really very difficult to do. Number two, only work for certain function that would always give you good, geometric shapes. So the last one is use a fundamental theorem of calculus of actually using antiderivative to find the definite integral. So that's the reason why they share the same integral sign. So now let's look at one of the first method. That means find the definite integral 0 to 2 x squared dx. You can interpret it as, if you look at this, you can interpret it as find the area under the curve of x squared from 0 to 2, right? In 5.1, we try to estimate it by using like 4 rectangle left and right. Now we are going to actually find the real number by writing it as a limit and then use those limit formula. So how do I do it? So first of all, I'm going to do the limit. So my f of x is x squared, right? And then my boundary is from 0 to 2. So delta x first. Delta x is always b minus a, 2 minus 0 over n. So we're looking at this first. So do the limit last. Just pretend that we are having n rectangle. I don't know what n is, but we just say 2 over n. So it will be 2 over n, right? What is xi? Because we start from 0, so it will be 0 plus, every time I advance 1, I do 2 over n times I, because it's delta xi. So f of xi on the right side, on the right endpoint, would be f of 2I over n, right? Because 0 I don't have to do. But my f of x is x squared, so that means 4I squared over n squared, right? F of xi. So now I'm going to expand this limit. So limit, or actually we would say I am actually wanting to do the derivative. Not derivative, the integral. The integral of 0 to x squared dx. I am going to do it as a limit later after I finish everything inside. Sigma I from 1, a lot of rectangle, f of xi is this one. So 4i squared over n squared. Delta x is 2 over n. Okay. So now these 2 over n and n squares are not related to the integrand, so I'm going to move it out. So this just still here. So 2 over n and also 1 over n square, I move it out. And then I would have sigma, well actually the 4 I can move it out too, right? This 4 doesn't make. So I would have I equal to 1 to n I square, right? So everybody know that this is, we have a formula for that. So that would be a limit. N approaches infinity, 8 over n cubed. And then this would be simplified as n plus 1. Remember, 2n plus 1 over 6. Okay, so I will be writing this as, so I'm going to do the limit now, right? So we can write this as, simplify this, because the next step we're going to do the limit and would have the area. We would have 8 over 6. We can simplify them later. And then I'm going to multiply this, but I am kind of lazy. Just multiply the first one because this is a rational function. 2n cubed plus something. But they don't matter because for a rational function of doing limit, all I want to do is the coefficient, right? Is the ratio of the two coefficients. So it'll be, when I do limit, this will disappear. It become 2 over 1. So this cancel. So after you do the limit of n cubed over n cubed plus something, it doesn't matter. Because when you do the derivative, this all goes away, or using L'Hopital rule or the infinite limit theory, so it becomes 8 over 3. So that means the area under the curve from 0 to 2 for x squared is 8 over 3. Okay, by limits of Riemann sum, and you see that it's quite difficult. Okay, so there's another one that I will do. I'm going to do it in the next video. 5.2 part 2 in the next video.